Hi guys, welcome to the fascinating world of marine electronics. This is our new class, our new course, Marine Electronics, and we are going to study why the electronics are important for a marine engineer, for a marine technician. I explained to my students that the electronic portion of this career is very important because the majority of the problems, marine problems, every day, when you have a marine problem, at the end of the day, 95% of the problems finish in an electrical problem or electronic problem. And this is the key word. You need to know about electricity and electronics. Those are two important areas in this career. If you want to be a successful marine engineer or marine technician or a master technician, you need know a lot about electrical and electronics components. Okay, every day when I visit the boat shows in this country and in other countries, I found that the majority of innovations, the majority of inventions are located in the area of electronics. When I visit the stands of electronics, I found that great innovations, more than other areas. I found that year per year in electronics, there are a lot of research. There are a lot of engineers working in order to create a new equipment every day, better, more autonomous. And this is the key word. Too much people ask to me, why, Mr. Lopez, you start your book and in the first chapter, you talk about robotics. Yes, I start my book with the topic robotics. Is because the boats are every day more sophisticated. The boats are every day more autonomous. And the boats are similar to the robots. The boats internally have a lot of equipments, and those equipments are small robots. Yes, there are a lot of internal robots in your boat. For that reason, one of the definition is, what is the meaning of robot? A robot is a mechanical intelligent agent which can perform tasks on its own or with assistance. Yes, this is a good definition for a robot. And what is in technical terms, other definition for robots? In practice, a robot is usually an electromechanical machine which is guided by a computer and electronic programmation. The robots can be autonomous or semi-autonomous. And this is the key word. For that reason, I mentioned before that every day the boats are more autonomous. And every day the boats are more independent. If you check a boat, you can administrate your boat every day in your pocket, in your computer. Yes, this is magic. But every day there are more components inside of the boat integrated here in the main screen, in the computer of your boat, or in your computer in your hand, your cell phone. Yes, you can start the engines here, you can start the generators, you can stop the engine, you can program the temperature, the air conditioning equipment. I am going to start the central air conditioning equipment at 6 a.m. and we are going to stop the central hydraulic unit at 5 p.m. And you can control the cameras, you can control the temperature, you can control the power. I can control here that if the shore power on the dock, on the pedestal is disconnected, immediately the generators start automatically and provide power and keep the battery chargers working. And this is completely intelligent. Your boat is in your hand right now because the electronics advantage. And how this is possible? This is possible basically because in the brain of each equipment is a circuit board. And those circuit boards can be integrated with a central expressway. The expressway is the backbone. In the backbone, you have the protocols. You have the language of communication of each equipment integrated in the backbone. And all of this information is moving back and forward in the backbone, and each equipment use the information related with the brain of each equipment and return into the backbone. In other words, the backbone is the brain of the boat. And in the backbone, you can integrate all the equipment. Yes, like the picture that you have right now on your screen. This is the central backbone. And you can integrate in the backbone generators, or engines, or air conditioned equipments, or GPS, or computers, or satellite TV, or transducers. You can integrate everything in the backbone, and you can administrate all of those equipments in one central screen, or central computer, or main screen. And you can administrate that central computer with your cell phone. That's incredible. And this is the situation that we are going to study in this book. We are going to study the procedure to do this connection, the connection of this wonderful picture. We are going to understand how can I connect everything together in one central unit. Okay, in order to do that, we need a start to understand some basic concepts about electronic components, like diodes, capacitors, transistors, resistors. And we are going to try to learn in a simple way the procedure to soldering and desoldering in order to replace a capacitor that is damaged, and the procedure to verify if the capacitor is damaged or not using the multimeter, you remember in previous episodes, or resistors. And you can recover circuit board like this, $2,000, $3,000. You replace a resistor or a diode, $1, $2, and you recover thousands of dollars in a couple of minutes. All right, we are going to try to learn the basic fundamentals of electronics. This is not a sophisticated book of electronics. No, this is a good complement for marine technicians, for marine engineers, in order to understand how to integrate everything together in a central expressway or backbone, and how to administrate the majority of the equipment in one central computer or cell phone. This is the idea of this class. And also, this class will be an excellent complement in order to take the NEMA certifications. I have a lot of information that the National Marine Electronic Association supplied to me in order to get to use too much tips in order to take those certifications. We are going to try to prepare in this class my students, my followers, in order to take the entry certification. We are going to start with the definition of an analog signal and digital signal. This is very important in order to understand why I have analog equipments and digital equipments. How can I storage those signals if it's possible? How can I transmit those signals if it's possible? How can I improve the environment in order to transmit those signals better? And how can I connect those signals into the computer? And how can I convert those signals into mechanical movements with solenoids? You remember? And this is this book. This is this fascinating class. Okay, guys, we are going to continue with the second part of this first episode. The second part of this first episode is related with the second chapter of our electronic books. The second chapter is related with the signals, digital signals and analog signals. And before I continue with the explanation about the analog signals and digital signals, I want to mention something about the classification of the elements in the periodic table. I emphasize all of my courses, basically all of my courses start with the periodic table, and how the elements are located in the periodic table, and why those elements are good or not good for the marine environment. In my opinion, one of the most important fundamentals to be a successful marine engineer is the inorganic chemistry. This is one of the courses that I recommend to yours if you want to be a successful marine engineer or marine technician, is if you have a chance, take a class of inorganic chemistry. Remember that the chemistry is divided in two branches, in two main sections, organic and inorganic. The organic chemistry is basically the study of carbon. Carbon, oxygen, and hydrogen, but it's carbon. The study of carbon and the interaction of carbon with other elements is organic chemistry. It's one branch of the chemistry dedicated only to the study of carbon. It's huge. All right, and the other one is inorganic chemistry. Inorganic chemistry is the study of the metals and non-metals and how they interact together, inorganic. And our topic, the marine engineering, depends a lot of this branch, the branch of inorganic chemistry, and how the oxygen attack the rest of the elements, and how the oxygen produce corrosion, and how the corrosion destroyed your boat. For that reason, in our book of corrosion, we are going to study the periodic table from this point to that point, completely. And we are going to study why the elements are located in one group or other group, and why some elements are more nobles, less nobles, the sacrificial anodes, and why this element is used to protect the other ones, and a lot of information related with inorganic chemistry, and a lot of information related with the periodic table. This is the topic that we are going to cover in our course of corrosion. I recommend that class. That class is wonderful. It's one of my bestsellers. All right. In electronics, we mention all the time the semiconductors. This element is a semiconductor. This board is a semiconductor. And what is the meaning of that? What are semiconductors? Semiconductors are elements that in some moments work like metals and in some moments work like non-metals. You remember the division in the periodic table? This division, that section? The elements located over there are non-metals, and the elements located below are metals. And you remember that the elements located in this section are transition metals. The metals used to transport electricity, excellent conductors of electricity. All right. In this division, in this section, we found the three elements located in the middle, in the border, in the limit in between the metals and the non-metals. Those elements are carbon, silica, and germanium. Those three elements are called semiconductors. Semiconductors. What is the meaning of that? The meaning of that is that those elements, carbon, silica, and germanium, they change. In some cases, they are metals. In some cases, they are non-metals. Depending on what? Depending on external factors. Factors like the pressure and the temperature. Depending on the temperature, those elements become metallics or non-metallics. Yeah, for that reason, if you have a boat and the construction of the hull is in carbon fiber, you need to be careful when you install electronic equipment. You need to be careful if you bolted those equipment directly into the hull, into the carbon fiber. It's not recommended because the hull in carbon fiber, depending on the temperature, if the boat is working in the Caribbean in the middle of the summer, that hull is practically a metallic hull. And if the same hull, carbon fiber, is working in Alaska, it's a non-metal. Yeah, depending on that. For that reason, you need to take special considerations when you install electronic equipment in a carbon fiber boat. Because those boats, the structure in carbon fiber, become metallic in some moments, depending on the temperature. and or non-metal. All right, but those metals, those elements, carbon, silica, and germanium, are widely used to fabricate semiconductor devices like diodes, like capacitors, like resistors. The resistors internally are composed by carbon. And how the carbon is decomposed, how the density of the carbon, the resistor have more resistance or less resistance. And the diodes is a combination of germanium and silica. And the microprocessor, a lot of microelectronic components are fabricated in semiconductors materials, in silica, in carbon, in germanium. The circuit boards are fabricated in semiconductors materials. For that reason, what is the enemy of the circuit boards in any electrical or electronic equipment? What is the enemy of the circuit boards? The temperature. For that reason, in all the computers, in all the central units, the circuit board have a fan located in front, like the picture. The fan is always running in order to keep the temperature of the circuit board down and avoid that this board become metallic and produce shorts and burn the circuits. Yeah, the enemy of the circuit boards is the temperature. Why? Because the construction, the material for the circuit board is with semiconductors materials. And the semiconductors materials become metallic when the temperature increases. All right? That's the reason why your laptop, your computer have a fan internally, and when the fan is not working, the temperature increases and the screen start to work properly and suddenly stop for high temperature. All right? That's the reason we are going to use a lot of semiconductors devices like capacitors, transistors, diodes, and we are going to keep excessive attention on that on those equipments in order to keep the temperature of those elements as low as possible. Yes, the enemy of the electronic equipment is the temperature. For that reason, you need to pay excessive attention when you install any equipment in a boat. All the equipments in a boat are electronics. I am going to install a new battery charger. Okay. There are a lot of considerations. You remember a.c.r recommendation when you install a battery charger. One recommendation is install the battery charger as close as possible to the battery bank. Okay, this is good. Never install the battery charger or inverter over the batteries, because the fumes, the gases produced for the acid on the electrolyte on the battery affect the circuit board and corrode the circuit board. This is other important consideration. And other important consideration is install those equipments in a properly ventilated area in order to keep the temperature of the circuit boards working properly, or install additional fans in order to circulate the air around those equipments. All right, the temperature is critical in the operation of electronic equipment. In this course, we are going to install a lot of electronic equipment, radars, GPS, transducers, a lot of computers, and we need to install those elements in areas properly ventilated. This is one of the most important parts. That's the first one. And the second one, we are going to install those equipments, those circuit boards, those elements properly ventilated with a low temperature, and also in areas where the electromagnetic interference is practically zero. The enemy of those circuit boards is high temperature and high electromagnetic interference. Be careful with the electromagnetic interference. You remember what type of equipments produce high electromagnetic interference? Yeah, alternators, inverters. Those equipments, the start motor, the alternators that produce excessive electromagnetic interference. That's the enemy for those electronic equipment. All right. Okay, with that information, right now, we are going to start with the definition of circuits and what is the meaning of a circuit board. For example, electronic circuit. An electronic circuit is a closed pathway of semiconductor devices packaged in a discrete form of soldered together to a printed circuit board in order to produce analog or digital signals. This is a good definition. This is a definition from other author. I found that definition good for our book, and I used that definition in order to explain to you what is the meaning of a circuit board. But in other words, a circuit board is a pathway of circuits integrated in one unit. Yes. For example, this is the circuit board for a generator. In this circuit board, you found the different pathways with different inputs and outputs. Those are the inputs and those are the outputs. Okay, each pathway starts in one point of the input and finishes in one point of the output. You have one pathway for the fuel system. You have another pathway for cranking. You have another pathway for running. You have another pathway for stop. Different pathways integrated in one board. Oh, my engine runs perfect, everything is good, but it's impossible to turn off the equipment remote. I need to stop the engine directly from the bottom. Probably the pathway for stop is damaged. Oh yeah, and if I check the pathway for stop, one resistor in the middle is burned. Probably I need to remove the resistor with the soldering device and replace the resistor for other one the same path. And right now I check, can I stop remotely? Perfect. I solve it. I recover that board. Okay? The circuit board is basically a condensation of pathways together in this board, in this special board fabricated in semiconductor materials. All right, and the signals. Right now we are going to start to check the analog signals and the digital signals, and why we founded both of them in our equipment, and why we need in some cases digital, and why we need in some cases analog, and what is the advantage of analog over digital or digital over analog? We are going to check right now what is that. The signals. A signal is a graphic function showing the variation in time and space about the behavior of a phenomenon. This is a good technical definition. It's basically the graphic of the variation in the time of factors like the voltage or intensity versus the time. This is basically an electrical or an electronic signal. Okay, the waveform. Remember, until today we know two waveforms. The DC waveform is a straight signal, DC direct signal, and the AC current, the alternating current, AC current. Those are the waveforms that we know until today. But right now we are going to understand the difference between analog and digital. Okay, a waveform is basically a visual representation of the variation of the voltage and current over the time, like I explained before. They are classified in two groups, unidirectional, and bidirectional. All right? If you remember, until today, we know two different forms of waves. The DC is unidirectional. And the AC is bidirectional because go into the positive and return into the negative and change the polarity. This is bidirectional. This is the simple explanation. The unidirectional is the DC signal. Bidirectional is the AC signal, in order to understand easily this definition. What is the meaning of unidirectional? These waveforms are always positive or negative. And the electron flow in one forward direction and never cross the 0 point. Like the DC signal. The DC signal is positive or negative and goes straight and never cross the zero axis, the 0 point. That's the unidirectional. The bidirectional form, these waveforms are also called alternating waveform, the AC current. This is a great example. And they are alternating from the positive direction into the negative direction, constantly crossing the zero axis. All right, those are the bidirectional forms, and this is why those forms are used like analog or digital. And right now I am going to explain that difference. Okay, what is the meaning of a digital signal? The digital signal is a signal that converts the original input information into strings of bits before they are transmitted. For example, the radio signal will be on or off. The sound can be stored in a compact disc in a digital form. In other words, the digital signal, we are going to check later, can be stored. Why? Because the digital signals can be encrypted, and the digital signals can be, because they can be encrypted, they can be stored easily in CDs, in diskettes, in different ways to store information. This is the digital signal. Other signal is the analog signal. What is the meaning of analog signal? The analog signal is a signal in which some features increase or decrease at the same time. For example, the amplitude, the voltage, or for example, the frequency. The frequency increase or decrease. You remember in our previous class of electricity, we can increase the frequency when we increase the RPMs. When the frequency increase, more RPMs are in 1 second or less. When you increase the amount of RPMs or the amount of cycles in 1 second, you increase the amplitude. All right, this is the definition of analog signal. Yes, the AC signal is an analog signal. It's a signal in which some features like voltage or intensity increase or decrease at the same time. The strength of the AM radio waves goes up and down in analogic form with the loud of the original sound. AM signals. In analog signals with amplitude modulated AM, while the amplitude of the carrier wave change, the frequency stays constant. In analog signals applications, the difference between the instantaneous and the base frequency of the carrier is directly proportional to the instantaneous value of the input signal amplitude. Yes, the AM signals, the name is modulated amplitude. What is the meaning of that? That the frequency can change more or less when you increase or decrease the period. Frequency modulated signals. Frequency modulation is an analog signal known as phase modulation. In those signals, the carrier phase modulation is the time integral on the FM signal. Yeah, those signals, frequency modulated, are signals where you increase or decrease the frequency with one button. More frequency, less frequency. Modulated frequency. There are two types of signals. Amplitude modulated, you increase or decrease the voltage, and FM, you increase or decrease the frequency. Frequency modulated and amplitude modulated. When you increase or decrease the voltage, the output voltage, you increase or decrease the amplitude, AM signals. And FM signals are signals where you modify the frequency. Those are good examples of analog signals. Okay, and now we are going to start to study what is the advantage of analog signal versus digital or vice versa. The difference between analog and digital technologies is that in analog technology, the information is translated in electrical pulses of variation of amplitude. In digital technology, the translation of information is in binary format, zeros or ones or zeros, where each bit is representative of two distinct amplitudes. Okay, if you check the picture on the screen right now, the analog signal is alternating signal, and the digital signal is composed by zeros and ones, yes or not, on or off, zeros or one. Once again, yes or not, zeros or one, or on off. This is digital. Okay, and now we are going to check advantage and disadvantage of each type of signals. In analog signals, the analog signal is a continuous signal which represents physical measurements of voltage and physical measurements of frequency. The analog signal normally have the shape of the sine wave. In digitals, the digital signals are discrete time signals generated by digital modulation. Normally, those signals are square signals, square waves. The analog signals are subjected to deterioration by noise during the transmission. That's an inconvenience. And the analog signals are affected, the efficiency is affected for external factors. Let me check what happened in digital. The digital signals can be noise immune without deterioration during the transmission and the cycle. But this is in some cases. There are cases where the digital signal can be affected and can be deteriorated. And the digital signal are, in general terms, less affected in noise and interference than the analog. The analog signals are more affected. The analog signals can be used in analog devices, only in analog devices, not in digital devices. The analog signals are excellent, are commonly used in audio and video transmission. When you want to transmit audio and video, the recommendation is use analog signals. If you want to encrypt it and storage, I recommend digital. Okay, the digital is best suited for computing and digital electronic devices. The digital signal can be stored in the form of binary bits. The analog signals and the digital signals. In terms of transmission of video and audio, analog signals. Those are the best. The analog signals are a little more expensive to manipulate, in comparison with the digitals. The digital signals are zeros or ones, yes or not, on or off. The digital signals are easy to be encrypted and stored in diskettes in comparison with the analog. The analog signal can be transported directly. You remember the AC power? The AC power is produced in the hydroelectric central or thermonuclear plants and is transported directly to the neighbors with the step up and step down transformers, and immediately the power is on the neighbor and the neighbor use the power immediately. The DC signals can be stored in the batteries and can be transported in the batteries for a long period of time. The digital signals are similar. The digital signals are encrypted signals that can be stored and can be transported easily. And both of them can be affected for noise and interference, but the analog can be affected more than the digitals, depending of external factors. For that reason, in both of them, the enemy of both signals is the temperature. Try to keep the equipment, doesn't matter if the equipment, the control box of the equipment is analog or digital, with a low temperature as possible. Remember, there are, for example, generators with the control box completely analog, with the relays, analog relays, and only wires, no circuit boards. And there are control box for generators, completely digital, with computer, with the circuit boards, and with all the electronic devices internally with the semiconductor materials. Those control box for digital generators, they have a lot of fans in order to keep the temperature of the control box as low as possible. The enemy of the circuit, doesn't matter if it's analog or digital, is the temperature. The idea is keep the temperature of those circuits, both of them, with a low temperature as possible. Okay, and this is the basic fundamentals of analog signals or digital signal. We are going to use both of them in different applications, in different forms, and we are going to integrate both of them in our central backbone in order to transmit, in some cases, sound, in order to transmit video, in order to transmit data. All of them integrated in the backbone. Yes, the backbone have the ability to transmit and transport both type of signals at the same time, and is integrated in one big expressway. I hope that you enjoy this class the same that I enjoy preparing this class for you.